This video will be about factoring. These first couple of videos are going to cover some of the most essential algebra skills that you will need in calculus. So let's go over a relatively basic factoring problem. We have 2x squared minus 9x minus 5. And your task in this case would be to try and factor this into two binomials. So remember, first of all, that you'll have two binomials that look like this. Now, most of y'all probably remember something that looks more or less like this. I don't know if this one's factorable or not. I don't think it is. But the problem with this one is this 2. So remember that when you are factoring something, these first terms of each of the binomial have to multiply together to get this x squared. So one of them is going to have to be a 2x and the other one is going to have to be an x. Now another thing to keep in mind is that the last terms in each binomial have to multiply together to get this 5. So the only way to multiply together to get a 5 is to multiply 1 and 5 together. So it's either going to have to be a -1 and a positive 5, or a positive 1 and a negative 5, or a -5, positive 1, or a positive 1 and a positive 5 and negative. So you've basically got 4 different options here. And you've probably seen in the past different quote-unquote rules as to how to find those numbers. Just remember that somehow those numbers are going to have to add up to be -9. However, this 2 throws a kink into that mix. So really the only way to do something like this is to have experience, or to get experience, which you have to get through practice, or to just randomly try some of those combinations. So let's try -1 and positive 5. So if I try this and I test to see if it works, I would actually multiply everything out again. So I'd get 2x times x gives me a 2x squared. That matches up correctly here. I'd multiply 2x times 5, and that would get me a positive 10x. And then I'd multiply -1 times x, and I'd get a negative x, and the -1 times 5 gives me a -5. So combining like terms, I get 2x squared plus 9x minus 5. And we go back up and look at the original problem. Well, this was a minus, so we didn't factor this correctly. So, but that tells us that there wasn't really much wrong with it, except for something's wrong with the signs. So let's try an alternative one. Let's try 2x plus 1 times, x plus 5. Let's see if this one works. So I multiply the 2x times x, and I get 2x squared. I multiply, oh, I'm sorry, that's supposed to be a -5. There we go. So 2x times x gets us the 2x squared, and now I multiply 2x times -5 gets us the -10x, and then 1 times x gets us a plus x, and 1 times -5 gets us a -5. So combining like terms, I get 2x squared minus 9x minus 5. So there you have it. So again, the key to factoring something that looks like this is to first find out what your first 2 terms are. So remember that these 2 terms have to multiply together to get this term, and then the last terms have to multiply together to get this last term in the original thing. And then you just have to try all of the different combinations within that, and then eventually one will work. And in this case, the second one that I tried was the one that worked. Okay, so let's look at some other factoring techniques. one of the most important factoring techniques is called the difference of two squares factoring. If you ever have something that's a number squared minus a number squared, you can always factor that out to be the first number unsquared minus the second number unsquared times the first number unsquared plus the second number unsquared. And if you went back and looked at, or if you were to distribute all this out and multiply it out, you would see why this is the correct factoring for something that is of this form. So let's look at an example here. We've got x squared minus 4. So in this case, a equals x and b equals 2, not negative 2 or 4. Notice that this negative sign is outside of the b squared. I don't take that with the b when I'm looking at things. So the correct factoring for this would be a minus 2 times a plus 2. Okay, let's look at another factor, another difference of two squares. Let's have 9x squared minus 4y squared. So we've got two different variables in this one. So you have to really try hard to find out what your a and your b are. So in this case, the a is going to be, sorry, not 9x. It's going to be 3x. And then b is going to be 2y. And so you can check that out. 3x squared, or a squared, would get you to that 9x squared. And then 2y squared would get you back to that 4y squared. So if I squared this, that would get us back to the 4y squared. So writing out the factored form of this, that would look like, 3x minus 2y and 3x plus 2y. And that's it. It's also important to note that if I rearranged these factors, remember factors are separated by multiplication signs, so in each of these individual parentheses, this is one whole factor and this is one whole factor. So I could actually rewrite these factors in any order, because we know that a times b is equal to b times a. Okay, so let's look at another important factoring technique. Remember, you can pause this video at any time if you want. This is called a perfect square factor. So if I ever have something that looks like a squared plus 2 times a times b plus b squared, that can always be factored into a plus b squared. Now, this one will look confusing because most of the time when you're doing a perfect square, you're trying to take it from this already factored form and turn it into the non-factored form. But it is very important to know how to go back and forth. So let's look at an example for this one. Let's do x squared plus 4x plus 4. Now, a key to recognizing if it's a perfect square is to find out, notice that this middle term is always going to be 2 times the unsquared version of the outside terms. So if I see that a is going to be equal to x, well then let's just see if b equals 2 would make it look like this. So if I have x squared, if I have a equals x, so then I put the a, or the x into the a here, I get x squared plus 2 times the a was x and the b was 2 plus b squared, which would be 4. Does x squared plus 2x times 2 plus 4 get us to this 4x squared? And so yes, it should. So the correct factored version of this would be x plus 2 squared. Okay, so now I'm going to give you a couple of more difficult sample problems. I encourage you to pause the video and try them on your own before you advance the video. So first of all, I want you to try and simplify. Oops. Oh, that doesn't matter. No. Sorry. I want you to try and simplify this in whatever way you think is possible. That could be factoring, that could be distribution. Whatever way you think is possible, I want you to simplify this expression. So go ahead and pause the video and try that on your own. I am now going to show the solution for this. So for this one, I notice that there's an x squared here, and I'm pretty sure, based on what I showed you earlier, this x squared is going to come out to be something with this x squared. Remember the perfect square expansion? If there's a plus b squared, that would be a squared plus 2ab plus b squared that I just showed you. Well, that's what this is right here. So I'm going to leave this x squared alone, and I'm going to put minus, and it's very important to keep these parentheses because of this minus sign. That minus sign needs to be distributed into the parentheses when you're done. So my a is going to be x, so I have x squared, and then I'll have plus 2 times x times h, oops, that's not an h, plus h squared. Now if I distribute that minus sign, I have x squared minus x squared minus 2xh minus h, oops, can't write those h's, minus h squared. So notice here that those x squareds will cancel each other out, and all I would be left with is 2xh minus h squared. Now if I wanted to, I didn't necessarily specifically tell you this, but it's very, very important to realize that this, notice that both of these terms share a negative h. So if I wanted to, I could factor out a negative h like that. And like I said, it's not always asked for you to do this, but this might appear as an answer choice whereas the previous one might not. So that's why it's important to know how to factor things at the end. Okay, let's look at another more difficult one. We have, x to the fourth minus 10x squared plus 9. So go ahead and pause the video and try to factor this one on your own. So what I see here is this is actually of the more basic form that we went over at the beginning. See, what I see this as is x squared minus x squared plus 9. So in order to get this x to the fourth out of our two binomials, what we're going to have is an x squared as the first term. So the next thing we have to multiply to get this 9. I'm going to pause the video here for a second. Okay. So then we have to think, well, what are some ways that we can get a 9 over here out of these last two terms? So we can either have a 3 times 3 or a 9 times 1. Well, if we look at the 3 times 3, notice that these have to be negative, so either the 3 has to be positive or they both have to be negative to get the multiplication to 9. If we have a plus 3, well, there's no way to get a negative 10 here, so let's try negative 3's. But notice that if we did a negative 3 plus negative 3 would get us to a negative 6, which is not the 10 that we wanted. So what we'll have to do is a negative 1 and a negative 9. So just to check to make sure, x squared times x squared gets us the x to the fourth. X squared times negative 9 gets us a negative 9x squared. And the negative 1 times x squared gets us a negative x squared. And the negative 1 times negative 9 gets us a positive 9. So if I combine like terms, that would get us back to this original. That tells us that this is the correct factored form. Okay. I'm going to have one more problem that I want you to try on your own. And this one, there are actually a couple different ways to solve this problem. So solve it on your own, and then we will come back and talk about it in class and have a discussion on this one.